Now that we have concluded differentiation, we are going to start the second part of the calculus unit, then that is integration and antidifferentiation. We're going to start by defining what antidifferentiation is. Antidifferentiation is the process that is opposite or that undoes what the differentiation process does. So it's the contrary operation to the derivative. Let's assume we have a function given by x squared. Then we know that the derivative is going to be 2x. But there is another important result to be considered. Let's think about all the functions that may have a derivative of 2x, and they are going to all be of the form x squared plus a constant number. X squared plus 1, x squared plus 2, x squared minus 3, they all have derivative 2x. So in general, the function f of x equals x squared plus c is the function that has a derivative equal to f of x equal to x. Now, what is the process of antidifferentiation? Is the process of, okay, if I have the derivative, how can I go back to find the original function? In most cases, you are not going to be able to do it unless you have additional information to support your work. For example, how can you know what the antiderivative of 2x is going to be? You don't know the answer because there are an infinite number of possibilities, an infinite number of answers. So what do we do in that case? In that case, we say, okay, the function that has a derivative of 2x is the function of x squared plus some constant that I don't know. So in the process of antidifferentiation, what I'm doing is trying to find the original function based on the derivative, and most of the time I won't be able to do it exactly because I will have to consider the possibility that there was a constant added to the function. So the antiderivative of 2x is going to be x squared plus the constant c. Let's consider another example. Take the function y equals cosine of x, and we want to find what is its antiderivative. So we need to think of cosine of x as cosine of x was the derivative of the function, so f dash is cosine of x. What function has a derivative equal to cosine of x? Well, we know that the function that has a derivative of cosine of x is going to be the function sine of x. However, there are many possibilities. You can have sine of x plus 1, minus 3, an infinite number of combinations. So what you want to do is actually say the antiderivative is going to be sine of x plus some constant. Similarly, what if the function is 1 over x? What would be the antiderivative? So I'm thinking the derivative is 1 over x. What was the original function f of x? This is going to be ln x plus c. The notation that we are going to introduce is f of x with capital F is going to represent the antiderivative of the function f of x. For example, find the antiderivative of the function f of x equals 3x squared. So we are not going to use notation as if this was a derivative. This is going to be a regular function. And when we find the antiderivative, we're going to recognize it because we're going to use the capital version of this letter. So the antiderivative of f of x would be f of x equals, and then which function has a derivative equal to 3x squared? The function would be x power 3 plus a constant value c. Now we'll introduce the symbol that we're going to use to represent the operation of antidifferentiation. And that symbol is the integration symbol or the integral symbol, which is an elongated S accompanied by a differential in x. So how are we going to read this? Anything that is inside is the function that we are going to be looking for the antiderivative. And this differential is telling you which of the variables that you have in the function is the one that you were differentiating originally. So, for example, when you calculate the integral of 2x dx, what this is telling you is the function that you have inside, which is 2x, was differentiated with respect to x. What is now the function that you had originally? So now we know, because we already talked about it, is going to be x squared plus c. Similar with the cosine function that we did before. The antiderivative of cosine of x with respect to x, that was sine of x plus c. Similarly, we did the antiderivative of 1 over x with respect to x, and that was natural logarithm of x plus c. So, whenever you see this symbol, what we are doing is we are attempting to find the antiderivative of whatever is inside of the symbol. Notice that the symbol itself contains two parts, so you cannot write one without the other. You must write both parts together. The function will go in the middle. So we are going to call the integral of f of x dx equal to the antiderivative of the function.